All right, I wanted to look at these questions here. Just if you're getting this, just to help explain a couple mistakes that we saw. So, first one wanted us to calculate the molecular weight of calcium chloride. Most common mistake here was missing the charges and therefore getting the wrong molecular formula for calcium chloride, but it should have been CaCl2. And then you got one calcium at 40.08 grams and two chlorines at 35.45 grams. And I came up with 110.98 grams per mole. But common mistake, it was just missing a chlorine. And that would have affected on the next one because this should have been calcium chloride, same type of thing. And then the hexahydrate is just 6 waters. And it actually is sometimes called calcium chloride 6 hydrate. And that terminology popped up because we do get some of these that form like fractions. So like calcium chloride 2.5 hydrate. But this is the one we're looking at, calcium hydrate. And we do the same type of thing to get the molecular weight. But almost everybody who missed it was just missing that 2 for the chlorines. So your mass was off by just that 2. But there'd be 12 oxygens and then 12 hydrogens and 6 oxygens. And I ended up with a molecular weight of 219.08. Alright. Turns out the third one was the one that caused a little bit more confusion. Now there are a few different ways of actually calculating this, but I was going to show you this. The way I'm going to show it to you is mainly based on a little bit more to try to explain what I'm doing on the logic. Alright, so the 1705, that really came back from, that's the approximate weight of that, the contents of that 4 pounds. And then I just added some significant figures, like if I would have actually weighed it on a scale. And we're doing this calculation based on, this is 100% calcium chloride. But to be honest, if we went and bought some DampRid, there's a good chance some of it's already been hydrated. So it's not going to be 100% calcium chloride. But what we're going to do to figure out the mass of water that's going to be absorbed, we are just going to figure out how many moles of calcium chloride we have in here. Now this will make sense when we actually look at this a little bit more. So, all right, so the molecular weight there, that was 110.98 grams. All right, reason I did that is because if it's actually going from calcium chloride to calcium chloride hexahydrate, we would know for every 1 mole of calcium chloride, it should be expected to absorb 6 moles of water. Because the interesting thing is, we could have got the mass of the calcium chloride hexahydrate that be formed, but I really want the water, and that's all I really care about. And I happen to know, because of that hex, every one of these absorbed 6 waters. So I got this nice mole ratio that we can use. And that pays off because 1 mole of water, we can get the molecular weight of it. And we can just go right across to the calculation. So that 1,700 grams of calcium chloride should be expected to absorb about 1,660 grams of water. So almost expected to double its weight or absorb its weight in water. And the neat thing about this, if you actually do get some DampRid, you will find it typically absorbs a little bit more than that because the solution of calcium chloride, being supersaturated, will actually still absorb more water. So it actually absorbs more than its weight. But the container would no longer be dry. It'd be filled with some calcium chloride water. So if it were to tip over, it's spilling water all over the place, or a solution. All right, thank you.